Hi everyone. Today's topic we are going to cover virtual circuit and datagram networks. So in this what are all the things we are going to discuss about is based on connection oriented service and connectionless service. First one is datagram network provides network layer which is a connectionless service, and virtual circuit network provides network layer connection service. Analogous to TCP or UDP connection oriented, so that means connectionless transport service layer. But what are all the services between the host to host? And no choice of the network provides one or the other. And the implementation is with the core network. So whatever the networks we are using, either it may be a mobile network or it may be an enterprise network or it may be a home network. So the implementation will be in a core network. Virtual circuits, the source to destination path behaves much like telephone circuit, which performance wise we can able to categorize it and the network action analog along with the source to destination path. So whichever the actions we are going to send a packet from source to destination, between we should be aware of the which path we are going to select it. So based on the performance we will be evaluated. So for initiating this virtual circuit we need to be call setup, tear down for each call before data can flow. Each packet carries a virtual circuit identifier, that is which is not a destination host address, and every router on source to destination the path maintains the state for each passing connection. So here the term state refers to the either it may be a state or it may be a stateless, that means which is a connection oriented or it will be a connectionless service. So like we need to be use this link router resources, like bandwidth and buffers may be allocated to virtual circuits, so which will be the dedicated resources to the predictable services. VC implementations, we will be using a virtual circuit implementations, which consist a path from source to destinations. So virtual circuit numbers is a required one, so one number for each link along path. So the entries in forwarding table in routers along path, so that the forwarding table which contains the informations of the source number and the destination number, whatever the labeling the packets, that packet informations will be available in the forwarding tables. So packet belonging to virtual circuit carries virtual circuit number rather than destination address. Virtual circuit number can be changed on each link. That means a new virtual circuit number comes from the forwarding table. We can fetch the informations from the virtual circuit. And this is the main principles and goal of this chapter. We should be known about the network layer services model. So the connection setup. So the important one is how the connections will be set up based on the architecture of ATM frame relay and X.25. So these are the some of the algorithms we will be using for defining the connections. So network versus transport layer connection services, which between the two hosts, from where we are going to communicate, and whereas in the transport layer the communication between the two processes. Okay, so these are the two differences among them. So which one will be the guaranteed one? So that is the most important in this network connections. So here we are going to discuss about that transport segment from sending to receiving host. So in this picture they have been clearly stated how the data will be transmitted from one host to another host. So based on the setup, how the network layer will be implemented on it. So on sending side, it encapsulates the segments into datagrams. So that means the segmented part, the datagrams will be segmented. So on the receiving side delivers the segment to transport layer, so that while we are sending it to the transport layer, it will be easy at the end users to communicate with the other node. So the network layer protocols in every host, that is the router. So the router examines the header fields in all IP datagrams passing through it, whichever the network, either it may be a home network or enterprise network or mobile networks. So whatever the interface from node to node can be able to communicate through this network layer. So here they have been maintain two key network layer functions. So one is forwarding and another one is routing. So forwarding means we will be move packets from router's input to appropriate router's output. So this is the work functioning in the forwarding. Whereas while we are using a routing, it determines the route taken by packets from source to destination. That is, we have to be define the path. So from where to where we are going to travel it, we are going to send the packet through. So based on the routing algorithms. So routing algorithms like BIG, RIP and OSPF. So these are the some of the routing algorithms. So we can define the path. And analogy routing, so the process of planning trip from source to destination, and the forwarding is the process of getting through the single interchange. So these are the two concepts we may be aware of in this concept. So interplay between the routing and forwarding. So routers algorithm will be using some of the routing algorithms to determine the end-to-end path through the networks. So for this purpose, we are using some of the routing algorithms, and then we are using a local forwarding table. So in this local forwarding table, the informations like source IP address and destination IP address and the labeling, the path labeled. So all these informations will be stored in the local forwarding table, and the header value output link, that will be in a hexadecimal format, so that according to that the number of values may be using it. So here in this picture they have been clearly stated when the packets are arriving, okay, which contains the packet header information. Okay, the header information will be as a hexadecimal value. So it will be passes through a routers. So one router to another router will be connected through, so that the pathway will be determined. So which pathway will be moved on. So here it will be labeled the interconnected. So in between, it will be connected from one router to other router. It will be labeled as 1 2 3 likewise. So what at the initial level the packet is arriving, so the packet is either moving to the pathway through 1, or through the pathway to the 2, or through the pathway to the 3. So these has to be determined by the routing algorithm. So as I said, the connection has to be set up, so that various service models has been used in this transporting datagrams from sender to receiver. So example services for individual datagrams is guaranteed delivery, because it is a connection oriented, so the delivery is guaranteed. And guaranteed delivery with less than 40 microseconds delay, so the time is very limited one. And whereas here the other one, the example of services for a flow of datagrams, in order to datagram delivery, guaranteed is minimum bandwidth to flow. So restrictions on charges in inter-packet spacing. So these are the drawbacks while sending through this datagram. So less guaranteed. And network layer service models. And here in this tabular they have been shown network architecture. So what are all the network architecture? Internet and ATM they have been used. Service model, various service models, best effort, CBR, VBR, ABR, UBR. So these are the service models they have been used. And the bandwidth is based on the it will be varied what type of network we are using it. So whether it is a guaranteed or not. So bandwidth and constant rate. Okay, so in that the bandwidth may be a constant one, and a few thing like ATM and using a VBR, so it will be the guaranteed rate. It will be high, and guaranteed rate is minimum with ABR. So these are the some of the criteria which type of network we are using on it. And loss and order, so what order we are using, either we are giving a prioritized order or we are using any queuing method we are using. So based on that whether either it is order is required or not. And timing, the next parameter is timing. So this one is based on the bandwidth, how much the bandwidth is consuming. So based on that, the timing will be measured. And congestion feedback, whether the congestion is occurred or not. When we are sending a huge content or large packets, okay, in that case, when we are sending the packets in a queue, there may be a congestion occurred. But request based services we are delivering means on that type of networks we can avoid this congestion. So these are the categories we need to be check before sending a packet. So these are the certain parameters to check in the service models. That's all about in this chapter. Thank you.